Hello everyone, welcome to this video and I am Shashank Kumar Rajak. I am going to give you a product demo of one of the products which I recently developed, and this product is an AI powered educational platform. This is basically a product which uses generative AI behind the scene to generate personalized educational content for students and learners. So what we can do through this platform and like how this platform has been designed, I'm going to cover this in this video. So first I will start with a brief introduction about the product, and then I will give you the product demo. We will go to the actual live website and we will see how everything is working, and then I will give you an overview of the technical architecture and how everything has been developed, and how different parts of this product has been connected together to build this one product. Okay, this is basically an AI powered educational platform, and it solves few of the problems which we students face while we are learning some new topics. At least I face this problem a lot when I'm starting to learn a topic, and let's say the teacher or professor, they are teaching some topic, and you don't know about the topic. You want to do a preliminary research about the topic. Okay, you want some reference material, some recommended resources, and how to like prepare the topic in the most effective manner. So you can come to this platform, you can just enter a topic, attach some notes or resources along with the topic, and the AI will create everything for you. It will create some personalized content. It will create summary for you. It will also create interactive quiz. That is the most interesting part of this application. You will get interactive quizzes in this app. It will also create a mind map for you to generate to give you a high level overview, or help you develop a mental model of what you are going to study. Okay, it will also create an audio overview. It is best for people who find it quite effective to learn through audios. So it will also create audio overviews, and it will also generate some recommended resources which you can follow to further study about the topic. So this is the overall product. Now let's go and see how this product looks like. So this is the product which is hosted live on my personal website. You can check out this website at eduai.shashankrajak.in. So you will come to this landing page, and then you can like first sign in or get started by creating an account to start using this platform. Sign up is required because since it's a personalized platform, so we need your personal profile, at least like a few basic details about you, like what language you prefer, which learning level you are, whether you are in college or school, or you are a professional. So it requires very basic kind of like your personal profile, and you can just sign in here. It does not require any verification. You can sign in, sign up, and just try out this platform, how it is working. So once you like create an account, you can go to the learning page. I have already created my account and I've already logged in here. So you can see like it will take you to this learning spaces page where all of the magic happens. And once you sign up, you will have to go to the profile page, and you will have to update your profile. Like I have done it here, like language, grade level, and gender. There are the three things which it will ask, and after that you can start using this platform. So what happens once you come on this page? So basically you want to learn a topic. Okay, so you want to learn a topic, and these are learning spaces which I have already created. I was testing this out, so I've created few of the learning spaces here, and we call these topics or these this place as spaces where you can learn new topics. So you can just go to here and create a new learning space for you. So you can enter a topic name for whatever you want to study, and you can also attach a PDF resource. Let's say it's a class note or some chapter from the book, okay, which you want to study, and you want to like quickly have a summary. You want to know a gist of the topic which you are going to study, so that tomorrow if your teacher or professor or whosoever is teaching you, if they start teaching it to you, you will be like prepared. You know what this topic is, and you will be like digesting those topics very effectively. Okay, it will help you better retaining every all the concepts, and you'll be a better learner at the end of the day. That is the goal. So let's say I want to study about Python programming. Okay, and now Python programming itself is like a kind of like very vast topic, but let's start with Python programming. And I don't have any PDF material with me right now, so I'll just start with the topic name to begin uh, a simple process. Now I'll just click on create a space. So first it will create a space for this Python programming. Okay, and then it will take me to the Python programming space page. Okay, and here you will see that summary notes, different sections are there, and it will first start loading up. And once the response is generated in the backend, it will be available here in the real time. You see, you don't need to refresh the page or anything. It will just update this UI in the real time as and when the content gets generated in the backend by generative AI. So we entered the topic name Python programming, and it created a summary note here, like what is Python, what are the key features of Python programming, basic syntax, practical examples, tips for learning Python, right? And some conclusion. Okay, so you can like read this summary, you will get some idea, okay, what is Python programming. So tomorrow if I'm going to learn Python programming, I know what is Python programming. At least I can have a conversation with people, I can talk about this topic, right? So this will help me generate this mental model. Along with that, it will also create a concept mind map, which I can like click here to zoom in. It will open it in a new tab. So it has created a mind map, right? Python programming, basic syntax and data types, practical examples. So this mind map is already created. Now I know like what are the major topics in Python programming which I have to follow, right? So this mind map also helps. I love mind map a lot. Like instead of writing, mind map is a better mental model to help retain the concepts. And then it will also give you recommended materials like Python crash course by Eric Mathis. And like there are different Google's Python class, Python for everybody, specialized on Coursera. So these are like some of the well-known recommended materials which you can follow to learn more about Python. So you can decide, okay, I'm going to study Python, so these are my resources, these are the like base tools which I'm going to refer throughout my Python journey. Okay, so it helps you do that preliminary research kind of thing before you start studying any topic, right? And uploaded sources are nothing, we didn't upload any material, so it is like empty here. Audio overview, I'll come to this in the last. But the most interesting part here is the knowledge quiz. Now it has created a quiz also for us. So what happens if we like take this quiz? Let's just see. Wow. So now we have a quiz, and this whole quiz is generated by generative AI. It's not some human sitting there who generated this quiz. And why this is interesting, because I remember like a few years back, I had created a test platform for like school students or people who are preparing for competitive exams. So there I had created this platform where teachers were creating the quizzes and students could take those quizzes. But now here with the like advancements in generative AI, it can generate a quiz in a given format. Like here it is MCQ. So it has created some 10 number of questions with a good options A, B, C, D, along with hint and along with the right answers or explanations, that too within just like few seconds. And that is the beauty of generative AI, I believe. So this quiz is completely like interactive, and you can like start attempting this quiz. So like what is Python? Let's say it's a language primarily for database management, high level programming language known for its readability. Wow, actually Python is known for its readability. That is what makes Python great. So yeah, that is the correct answer, and I earned 2 points also. Nice. So it is giving explanation. It also generates hints. Okay, like consider Python's design philosophy. So it really helps you think. Like the questions are quite good. I have tried with like a lot of quizzes during my testing of this platform, and I found the questions like quite compelling. I mean, they were quite thought provoking. It's not like they are kind of dummy questions. So like you can go to next question, and like you can see like there are different questions. Even if I like submit kind of like wrong answer, it will show me that okay, this is the incorrect answer, this is the right answer. And kind of like I can start attempting all the questions, and in the end it will give me a feedback. So this is like kind of an amazing like experience for learners. Like okay, now I don't have to go on the Google and search for different kind of like question banks or practice. Okay, we have just one resource, and there I get everything which is required to master a topic. I get a quiz, I get a like recommended resources, I get a summary, I get a like mind map, whatnot. Like we are getting everything like just under one platform, and that is also like AI is generating all this content for us. Okay, so this is great. Now the last feature is the audio overview. So fine. Now we will just click on generate audio overview. This is not generated by default because there are different factors. Like if I talk about engineering bottlenecks there, then obviously cost is one factor, because whatever text to speech service you will use, you'll have to pay some cost. So this is generated on users choice. So we will just click on generate audio, and it will start generating audio. It takes some time, and it generates the audio. uh, I think there is a small bug that it does not update the UI automatically, so that can be fixed. That is like not a big issue. But once the audio is generated, you will see like you can refresh the page, like if it is not updating automatically, and we can just play it.
Hey there, coding enthusiasts. Welcome to Python Demystified. Python's a Swiss Army knife, readable, multi-purpose. Simple syntax makes it easy to learn.
So like this is like it generated this 48 seconds of audio summary. And
Practice, build projects, join the community, read docs.
okay,
Python's
so it is like kind of nice. You can play around with this audio section. This generates the audio, and it generates the audio in English as well as Hindi language. Like if you have chosen in your profile your language to be Hindi, then the whole content will be generated in Hindi. Okay, so this is a great feature, I think. Okay, so the like next feature which I want to show you is like uploading the PDF along with the topic. So let's say we have some PDF resource with the topic which we want to study. Let's say I want to study about AI agents, okay, and I want to update this PDF along with this topic. So I'll just hit enter, and I will create this topic, and this will create like this AI agents like kind of learning space here. And it will use this PDF resource which we have uploaded. So now you can see like in uploaded sources, you will see this PDF document. Okay, and it will keep on generating. Once the content is generated, it will be available here. Like if you see this content, this is like kind of agents and environments PDF which we uploaded, right? So once the content is generated, it will come here. Okay, so it took some time because obviously there is PDF also which is getting used to generate the content. So once the content gets ready, it will be available here. It takes some time. Uh, so the summary notes is also created from that PDF file. Okay, and a mind map is also created. Recommended materials is also there. The knowledge quiz is also created. Like what is a rational agent? Okay, an agent that always performs actions correctly. Okay, so okay, this is a wrong answer, so it will tell you okay, this is the right answer, and then you can like start attempting all the questions which have been generated based on the PDF which we uh, uploaded. So this is how this overall platform is working. It like helps you learn in a personalized manner. It creates different kind of content for you: quizzes, audio summary, recommended resources. So it overall helps you to like learn in a personalized manner. Okay, so this is just an example of like what we can do like with the help of generative AI, and what sort of applications we can create, which are quite different from the traditional applications which we were generating like a few years back. Like the quiz example which I gave you, like if you have to create a quiz platform today, you can create it very easily with the help of generative AI. And also you can keep a human in the loop, so that there is some check on the kind of questions or what is being generated. Okay. um, so this is all about the demo of the app. Now let's go and see like how this app has been designed, what are the different components of this platform. So coming to the tech stack, like what tech we are using here. So the front end here is designed using NextJs, which is like the industry standard today. I think most of the applications, web applications, are designed using NextJs. So NextJs we are using like for the UI design. Along with that, we are also using Tailwind CSS and Shad CN UI for the UI library to design the UI in a faster way. And then the backend is designed using FastAPI. So it is using Python. So the server backend is using FastAPI. And we are using Supabase. Supabase is basically a backend as a service. So we are using mainly Postgres database and the storage from Supabase to host the files and to use the database, and for also the real time like updates feature from the Supabase. So that we are using here. Clerk is used for authentication purpose. It really, like, it is a great tool. Like if you are prototyping something, so Clerk is a great tool to add authentication in your web application. With just a few lines of code, you can add authentication and you can like focus on other feature development part of your application. uh, we are also using Amazon Poly, which is like a text to speech service, and it has like a lot of speech modules available. You can use it to like create text to speech in different languages. And the entire solution is hosted on AWS cloud. Okay, apart from this, there are other tools like LangGraph is used for agentic workflow development, and that is basically, I think, the industry standard today. People are using LangChain and LangGraph for agentic AI development. And for LLM model, we are using Gemini. Uh, so that I will talk more about when I show you the backend and the agent part of this app. So we'll talk more about the model and LangGraph part and how the agent is designed. So this is the overall tech architecture, how this overall like application is designed. Now coming to the agent workflow, how the AI agent is working. So I'll show you the agent workflow first, and then I will give you a walkthrough of the entire code base, like how the backend, the training, and agentic workflow code is structured and how different modules are working. So coming to the agent workflow part. So basically this application, the heart and core of this application is this agent workflow. Because I told you like this is a generative AI application. So basically we are using AI to generate new content. That is the heart and like soul of this entire application. There is no human intervention. There is no human sitting like who is going to process the request. Like a user is typing that I want to study about AI agents, and someone is sitting there creating quizzes and all those things. So basically for like automating this problem statement, we are using generative AI. So whenever user enters some prompt, we use that prompt and we generate some content. Okay, that is the end goal of this application. But we are not just creating a single asset like summary. Okay, we are doing different kind of processing when a user requests to learn something. Okay, and that is why agentic workflow comes into picture. This is not a simple like question answer kind of problem. And whenever we have some such type of complex problem where we are trying to solve a business problem which involves like using a lot of different processing, lot of agents, okay, a lot of processing. So we use this kind of workflow, and this kind of workflow is not new in the software world. uh, we have been using workflows like from like time, from a very long time in software world, right? Workflows are already there. But what makes this workflow different is that it uses like some kind of LLM interaction, and it's kind of a smart workflow, I would say, because it knows like what processing it has to do, and it can completely change like based on the user's context and what user is trying to process, what output is being generated, what nodes are to be invoked. whether it has to do Google search or use some other tool. There are a lot of complexities involved, and to solve those complexities we use such kind of workflow, and that is why we call it agentic workflow. Now we can design it from scratch also, like on our own, but today we have some industry standard open source frameworks like LangChain and LangGraph. Okay, so this is like LangGraph which we are using to develop this agentic workflow. So LangGraph is a family of open source tool from LangChain. So LangChain is one tool which we use when we have to develop something kind of like a chain. Like there's one prompt, then there is another prompt, and everything is happening in sequence. So in that case, we use LangChain. But when we are using such kind of workflows where uh, we can visualize it like a graph, then in that case we use LangGraph. So LangGraph is available for both Python and JavaScript, and I think Python is the first choice in AI world. So we are using Python here, and using this LangGraph, this workflow has been designed. So what happens in this workflow? Like before giving this graph tool overview, I'll show you like what happens to a user's prompt journey. So whenever a user enters some topic in this learning space, like here, whenever I want to study something, I'll go to the learn page and I'll create a new learning space, right? I'm entering some topic and I'm uploading some PDF. So this becomes kind of an input from the user in natural language. So that is user's input, and this is also like before this prompt also. So user input will be captured, and then it will go to the backend, okay, where we will have to generate a prompt. Now, prompt is the most crucial part of this application. How the prompt is designed, how the prompt is engineered, is itself an engineering task in itself, and today it has become a dedicated field in itself, like how to design the prompts, right prompts which give the desired output. So when the user enters something, the backend will take the user context from the Supabase database, or like wherever the database, whatever database we are using, we can use that to fetch source files like the PDF file and the student profile context, and then using this metadata we will prepare the actual prompt which we have to send to the LLM, the large language model, okay, which is going to process that prompt and generate some response. Okay, so when the user enters some query, we generate a prompt. I'll show you how that prompt is generated when we go to the code part. So once that prompt has been prepared in a particular format, okay, and that prompt we have already designed during our development phase. We have done a lot of iterations of the prompt, and we finalize a prompt which is working for us for our use case. Okay, so that prompt template which we have prepared, we will just use the user's query and the user's metadata, like some of the like context information which we want to use in the prompt, and then we will generate a final prompt and we will pass this prompt to the LLM expects a prompt as an input, right? And then LLM will use that prompt and it will generate a summarized content from that prompt, and that summary content we will use in other part of the workflow, because we don't want to process the same input again and again. Okay, so the first gate is like where we are using the user's prompt and creating a summary out of it, and then that summary we are passing to other uh, processors, kind of like we can call them nodes or agents. So those agents are then doing different things. Okay, different things, meaning like there's a, like this is the summary node which will first take the input and it will create a summary, and then that same summary will be used by these nodes to do the processing. Like this node is creating a recommendation, this is creating a quiz, this is creating a mind map, this node is creating an overview, the audio overview script. Okay, and then all of this agentic processing is happening in a parallel environment. Okay, it's not like node mind map is waiting that okay, first audio overview will be done, then I will start my job. No, everything is happening in parallel. Okay, but after this, summary has been generated by this agent. Okay, so this is the agentic workflow, that how the content is being generated from the user's prompt to the final all the assets which we want to generate. And all of these agents they are generating the content, and in the real time they also update their responses in the Supabase database. So what is the advantage of that? As soon as any agent has done completing its task, let's say quiz has generated the quiz, so it updates the Supabase database, and that database is subscribed in real time by the front end UI. So as soon as the quiz is generated, the UI will get informed that quiz is generated. Now you can show the quiz. Okay, so that is the benefit of real time updates, because this all of this parallel processing, this will take some time, like 7-8 seconds, like at least 7-8 seconds it will take. Okay, in a very like good scenario. But as the users increase, as the latency increase, as the load increase, it will take some time. So it's better to consider all of this as a background task, and not like make the user wait for like as long as this processing is happening. So we can tell the user that you can come back, we can show a loading UI, and in real time we can show the updates as the content gets generated. So this is the overall journey of a prompt from user's end to how the content is generated. Okay, and that is what this agentic workflow is showing here. So this is the core of this entire application. I mean, if we design this part of the application very effectively, and if this part is working correctly, then we can say that our application is working as per our expectations. At least we have designed it to like give us the desired output. Okay, there are other challenges which we can deal, but at least this is the core part of this application, which has to be like engineered correctly, such that we get the desired output from our product. Okay, so this is the agentic workflow part. And now I will give you the code walkthrough, and then we can conclude the video. So sorry. So basically, the code is hosted on GitHub repo. This is the GitHub repository for this project, Edu Assistant GenAI. I'll share all these links in the description box of this video, so you can check out the code base. You can download this code on your local platform. You should have Node.js and Python on your local system in order to run this. And the detailed guidelines have been already given in the README file. Like there is a backend folder, there is a front end folder, and there is a training folder also. I'll show like what each of these folders have. And to run this application, you will need to like run the backend. We need UV for this, so we use UV for package management in Python, and UV sync will install all the required packages in Python. Um okay, and then you can run the server, and then you can go to the front end. You can install all the npm libraries, and you can run the front end, which will run on this port, and then you can start playing with this. You will need some environment variables also, like clerk, JS, Supabase, and a Gemini model. So all those things you can set up and put in the environment variables, which already have been described in .env.example. So you can check out what environment variables are needed for back and front end, and you can start playing with this project. Now let's just see that how this project has been designed, what it takes to design a GenAI project. So basically, the GenAI project is not different from any other like software product. So it follows the same approach which we follow in designing any other software product, like ideation and market research, discovery phase, everything. So once we have the idea that okay, we want to uh, design this particular product, then we will have to select a model. Okay, so in this case, I've selected Gemini model because I was clear that I want to develop this as a multimodal input app, meaning that I want to input text as well as PDF file. So the model selection is done, and then we start playing with the prompts which satisfy our business use case. So this training file is kind of like a rough playground for us. I've included this folder here also because it helps see that how our training was done, what sort of experimentation we did during the development phase, which prompts worked, which prompt didn't work, because prompts are very crucial for our project. So we have to like store them separately, version them properly so that we can swap them when one prompt is using when one prompt is being like used and it is working correctly for our use case. So there are a lot of challenges there. So this training folder contains all the Jupyter notebooks which I used to experiment with the prompts. And this training agent Jupyter notebook, this actually contains the entire workflow code for this project. Okay, so you will see all the libraries which I have used, and like uh, different agents, like output structure. Okay, the agent state, different agent node, like to generate the node summary, I'm using this node. And this is the prompt template. So this is what I was talking about, that prompt engineering is a very crucial role. uh, it plays a very crucial role in this whole product. So prompts are designed here. Okay, and you can play out with this prompt, you can change this prompt and everything will change about this product. So that is why we have to keep a record of all these prompts, what output they gave, and which prompt worked for us. So we have to store them properly, version them properly, and use them in our product. I'm using this Gemini 2.0 Flash model. I'm also using it with structured output. So I have also created a structured output for all the model responses, because otherwise model will start answering in its own flavor, in its own tone. Like it will add a lot of text material, and that is good if you want to just show the user uh, the response which you get from LLM as it is. But if you want to use it in the way to create new UI elements, components, then you want a structured output. And we can do that with most of the LLM models today. And Gemini has a great support for structured output. So that is one thing which I like about Gemini. So you can pass this structured output like summary note output. So summary note output will have a title and summary. Okay, so likewise everything is defined here. Then for every node, I have written the code here with the prompt, structured output, prompt template, everything. Okay, and then everything is here. And then here we build the workflow. This uses LangGraph. So we are like initializing a graph with this agent state, which is passed to every node. And then we have created kind of a workflow here. So this is like agentic workflow, and this is the input state for the agent, the input which we give. So from the UI, when we enter some topic which we want to learn, this is how the input state is passed to the agent, and then it starts processing or creating the prompt. Okay, and then we invoke the agentic workflow, we validate the output, that okay, is it generating the right content. All of this thing has been done in this training file. And then there are individual files like to work on individual agents like mind map. So how mind map will be generated, what kind of output we want, okay, what state we need to pass, and how we will create the image from the output structure. All of this thing we have experimented in this training folder. Now the front end folder just keeps the front end code, which is Next.js, and which is not very complex. It you can check out this front end folder, and it's like any other front end project. There's nothing complex here. What is interesting is the backend folder and how an agentic AI backend is designed. So we are using Fast API here, and I'm using UV, and UV really helps us maintain all the dependencies and Python version everything. And I'm really liking this UV thing. It really helps structure the project. So that is the thing. And then we are using this src folder, and in src folder we have this main.py from where our server starts. And we are using Fast API and all the things. And here we have this route API/workflows. So this is the route where all the routes, public routes, have been designed. So you can go to this API folder, and here inside this routes, this workflow contains the routes which are used by the front end. Okay, so basically this is the API workflow invoke, which is invoked by the front end whenever a user starts learning a new topic. This endpoint is invoked with that particular learning space ID, which is created in the database. And then from here the agent starts doing its job. And you can see that we are using this background task from Fast API. So Fast API is really very simple to use actually, and it helps you create this background tasks which will run in the background, because you don't want your users to wait, okay, till the time this API is working, and then it will give a final response. No, we will run this agentic workflow in a background task. We will provide it whatever input it wants to run this agentic workflow. And for the audio summary, we have a separate endpoint, as I already talked, because we are not creating audio summary by default. It is on the user's choice that we create the audio summary. So whenever a user will request to generate an audio summary, this endpoint will be invoked, and whatever script has already been generated, script we are generating by default, and that script we pass here to the Amazon Poly, and it creates the like a kind of like text to speech for us. So you can see this function, which is here we are using Amazon Poly, and it synthesizes speech. We are using a neural engine which makes the sound more natural. Okay, and we are just passing this text input, and the language code is also like can be customized based on the user's profile, and then it creates an audio file in mp3 format, and it uploads it in the Supabase, and then it returns the URL for that. So this is how text to speech is working here. Now coming to this agentic workflow part, because this is the actual uh, like logic, business logic of this whole platform. So if you go here, we are invoking this agent workflow. This is again in the services folder. So this invoke agent workflow, what it does, it it creates this initial state which is required to invoke the agent. And you can see that it contains the student profile, and it also contains the user prompt, which is the topic he wants to study, and the like PDF URL which they uploaded. And then from there we initialize this agent workflow, and then we just call the invoke function from that agent workflow instance. So if you go to this agent workflow class, here we have a dedicated directory for agents, where we have kept all the code required for the agentic workflow. So we have this graph here, agent workflow, and this graph is the same LangGraph graph, where we initialize in graph, and then we add the nodes and all the edges required between all those nodes. Okay, and then we compile this graph. So you can see like there are different nodes: summary node, quiz node, recommendation node. And I showed you like how everything is like designed in this manner. So this is how that graph is designed. First this node, then all these nodes will run in parallel, and then there is an end node. So you can see like there is a start node, then there is a summary node, and then all these nodes are like running in parallel, and they all originate from this summary node. They depend on the output of the summary node, and then they are all ending. So this is how the edges and nodes have been designed, and then we compile this node. And then here is the invoke function, which can be called from outside of this class. So whenever like this agent workflow, here it is invoking this function with some initial state, because this state will be passed to the agent, and every each of these agentic nodes, they will have access to that agent state. Okay, based on which they will be performing their operation. And the state we are maintaining in this state file, if you see like this is the agent state, and it has access to all the variables which an agent needs in order to complete its task. Okay, in output structures, we have defined all the output structures which different nodes will be generating their output, like based on that output structure. So this file contains all the output structure, and this is the beauty of getting a structured output from LLM, which helps us to develop such GenAI apps. Otherwise, it's just natural language in which the LLMs are responding back. So we can tweak that output using these output structures. Okay, like if you see like this quiz, so the quiz output is coming in this manner. It has a list of questions. Okay, the list of questions, and each question will have this structure. Like it will have a question, it will have options, it will have correct answer, hint, and explanation. And options can be in this format. Okay, so the LLM will always try like respond back in this structure only. So this is the utility of this output structure file. And then in the nodes, we have all the nodes or all the different agents which are there. Like starting from node summaries, you see like this is one agent, and here we have this main function run node summary nodes, which is called by the graph. So here one more interesting thing I would like to add is that throughout our GenAI application, we should have proper logging mechanisms. Like here we are logging the info that this node is running. Then we should also log the state, which is uh, being sent to this node, because we should log the input and output both uh, during the entire journey of the agentic workflow, because we want to like debug how the user prompts was processed by the LLM, because these LLM responses are not like very deterministic always. They're not going to respond like the same response always. So we should have some kind of mechanism to evaluate our Gen AI based applications, whether they are working correctly or not. And to evaluate them, we should have proper logging mechanisms, that what was the user input, what was the LLM response, what was the output structure, and what was the output, final output generated by the whole workflow. So in order to achieve that evaluation and like kind of like evaluation task, we should have this logging mechanism in place. Okay. And while logging, we should also make sure that we are not logging anything private data related to user. So logging is important, and like Python gives this logging mechanism out of the box, and it's amazing here. Then we just log the agent state, and then here we are creating this prompt using chat prompt template, which is given by LangChain. So this is how a chat prompt template is designed. And this is the most crucial part, which takes most of the time of this GenAI based application during development. And here we are using a system role and then user role. So system role is used to like a kind of a set kind of a expectation from the LLM, that okay, this is your role, and you have to use all of this information and generate your response according to the system instruction. And the user role will contain the input from the user. So it is kind of a role based conversation, and LLMs can understand this type of conversation. And then finally they will create another message, which will be like AI message. Okay. So this is the prompt, and here we are using this variables which will be populated when we invoke this prompt template. And you can see that we are passing the user profile, like language, gender, what is the grade level, like what is the user content. All of these things is being passed in the prompt. And here we are initializing the model. Now here we are initializing the model, and for each of the agents we can use different kind of models also. It's not mandatory that you should always use a same model for all the agents. Here we are using Gemini 2.0 Flash. For some other agent like audio script overview, or like let's say tomorrow we want to generate some kind of video lecture out of this summary, so we can use Google View also, like I think it's View. So that can generate video content from like user prompts. So it is completely up to us which model we want to use in which agent. So that kind of flexibility we should have in our application. Okay. And then we have this chain. So this is the chain part which I was talking about. The LangChain allows us to chain different kind of functions. So here we are using prompt template, then model. So if we do it without chain, then we will have to first process this prompt template, then pass it to the model. Otherwise we can write it in this expression. uh, this expression have some name, I don't remember it. I think LECL or something. LangChain calls it some language. And using this pipe symbol, we can like chain different kind of components together. Like in a proper LLM based function, first we have to prepare the prompt, then pass it to the model. So this chain will take care of that. And then finally we can invoke that chain, and we can pass the required input here, and the response will be generated. And then once that response has been generated, we are updating it in the database. So as soon as it will be updated in the database, our front end will get like some kind of update that summary has been generated. Now you can show the summary. So that is the purpose. And here we are using with this model dump. So response.model dump, what it does, it like creates the JSON response out of that, and we use that JSON response because we want to use it further in our downstream applications. Okay, so we are not storing it as text uh, type, but we are using it as a JSON type. And then we also return something from here. Now this return is crucial because you see like it is returning something. So it received this agentic state, and that state we have to return from here. So when we return this summary notes, so what will happen that in this agent state, if you see that here, you will have this summary notes. So that node is updating this summary notes part. Likewise, each of the agent will update some parts of this state. It will utilize some part of the state, and it will also update some part of this state. And then at the end of the workflow, we will have this agent state which we can utilize further. So that is how every node works. And this is just one of the node. We have all the nodes here which are designed separately. So tomorrow, if we let's say if audio summary is not working correctly, for example, while I was developing, I was using SSML script for this generating this audio overview, but it was not working correctly because I think Amazon Poly has some restrictions on what SSML tags can be used or not. So based on that, I changed it to plain English script, and based on that, I did some changes in the node audio summary. So if some node is not working, then we can tweak that, we can change it separately. So that kind of flexibility we have in our application, and it helps in faster debugging, faster development, and faster iterations. So this is how the whole agentic AI backend is designed. And we should take care of the flexibility, we should take care of the part, which part require changes, iterations, so that we can do it without affecting other part of the applications. So that kind of modularity, flexibility we should have in our application. So this is the overall architecture and the code base of this app. If you have any feedback or any questions, I would love to hear them. You can share those in the comment section. Coming to the last part, like some of the challenges. So I think I already talked about the challenges while I was talking about this product. Prompt engineering is definitely one of the challenge, because that takes most of the part, and we should properly engineer good prompts. We should experiment with a lot of prompts. We should also take into account domain expertise while we are engineering the prompts, and we should keep a proper record of the all of the prompts, like prompt, its version, what model we used, like we should also record that, and what output we received, that also we should record it. And we should properly review those prompts. And one of the challenge is also the output structure. Like we want outputs in a proper structure, okay, if you want to develop good Gen AI apps, because otherwise LLMs just respond in human language, and they are very moody and they can respond anything, and that will just break our application logic, unless we just want to show the plain response which we get from LLM. We can always design good output structures. So that is also one thing to take care of. Logs and monitoring, I already told, like we should have proper logging mechanism, and that is also we should take care of. Evaluation, how should we evaluate a Gen AI model like this particular application which I have designed? How should I evaluate that it is working correctly? So one way is that when this app goes into production, we take user feedbacks, we take human feedback, and that is how we evaluate it. And apart from this, there are other mechanisms also, I think, which exist for proper evaluation. Like we can also use some LLM based evaluation technique also, which evaluate all this these responses which are being generated. And then DevOps is one of the challenge, like obviously where to deploy it, how to scale it. So that is same as any other software engineering product, like whatever we follow, because here we are not dealing with any complexity. I mean, the whole process is just like any other software engineering development project. So DevOps is just similar to that. So I think these are few of the challenges which we should take care of while we are developing Gen AI based applications. So this is all for this product demo video. And if you have any doubt, or if you have any questions, or if you want to connect with me, you can check out the description box for all the links and my social profiles where you can connect with me. Thank you, guys.